Hello. I'm going to do a series of little four-part mini lecture. This is part one about rational functions. This is one of the harder concepts of college algebra and rational functions. Anyway, you got to understand rational functions are two functions that if you divide two polynomials. So if you have two polynomials, let's say you have a polynomial on top and a polynomial on the bottom. That makes up a rational functions. So in order to graph rational functions, there's several steps that you have to do. And there's different characteristics of the graph. Just like polynomials have their own characteristics, where lines have their own characteristics, rational functions have their own characteristics. And since this one is probably a lot more characteristics than the others, like lines, for example, lines only have slopes and and then a point or two that you have to graph, and then you're pretty much done with the graph. This one, not so much. You have to worry about lots of different things. As in most functions, you do have to talk about intercepts, x and the y-intercepts. That's one of the first things you do. And but on rational functions, there are also other things you have to worry about as horizontal asymptotes, vertical asymptote. Um, does it cross the horizontal asymptote? Any oblique asymptotes? Now, while I'm here, the oblique asymptote is a concept we don't really talk too much about at this university, but there is such a thing as oblique asymptotes, and then trace the graph, and then there's holes in the graph, possible holes. And I created a little acronym that I can remember everything I need to do with this little sentence. I have a coat with holes. The I stands for the intercepts. The HA, of course, stands for the horizontal asymptote. The VA stands for the vertical asymptotes. The C stands for does it cross the horizontal asymptote. The OA, of course, is the oblique, and then the T is the trace. And so it's a little sentence to help you to remember what you have to do. Now, remembering the sentence, some people think that if you just remember the sentence, then everything is good. So I have a lot of people who will write the sentence down on the test, and that's all they see. Of course, you don't get any credit just for remembering an acronym. You got to remember how to do the things. So let me kind of explain to you what all these little things are. Of course, I didn't tell you what by now we all should know what intercepts are and how to find them. But the horizontal asymptote is talking about the end behavior of a graph. And you're only going to have a horizontal asymptote if the degree on top is smaller than or equal to the degree of the bottom. So for example, if you have a polynomial on top that's degree 2 and the bottom that's degree 2 as well, then you're going to have a horizontal asymptote. If the degree on top is 1, like if you have it like 2x plus 3, that's a degree 1. And you have like an x squared minus 5x plus 4 on the bottom, degree 2 on the bottom, so it's smaller. So that one will also have a horizontal asymptote. So those are the two situations where you're going to have a horizontal asymptote. Vertical asymptotes are talking about the domain errors. Now, at the very beginning, on the problem, you're going to want to simplify it. And once you've simplified it and you're done with the simplification, it's whatever makes the denominator 0. So, as you remember how to find intercepts, you got to set the function equal to 0, which is kind of setting the numerator equal to 0. So, every one of these problems that deals with rational functions, at one point you're going to set the numerator equal to 0. That finds your x-intercepts. At one point you're going to set the denominator equal to 0, and that's going to find your vertical asymptote. There may be more than one. And what the vertical asymptote basically tells you is this is the place where it's undefined. So ultimately you'll have a function that will have these little vertical dotted lines, and that tells me that the graph is undefined at those places. Also, you're going to be doing is crossing the horizontal asymptote. Now, do they always cross it? No, they don't always cross it, but sometimes they do. And right here it says, if you have a horizontal asymptote, this shows the location where the graph may, and the operative word is may, cross the horizontal asymptote. And to figure out the value that's going to happen at, you set the function equal to the horizontal asymptote, solve that, and then if it gives you an answer, for example, if it says x equals 4, then you locate x equals 4 on the horizontal asymptote, and you put a point there, and that's where it's like a doorway where the graph will go through. And then there's the oblique asymptote. Like I said a while ago, this is something we don't talk too much about it, and this is also talking about the end behavior, much like the horizontal asymptote is. If you remember a while ago, I said the degree on top has to be less than or equal to the degree on the bottom. That gives you the horizontal. But I left a little window open there. it could be greater than, right? So this is what happens here. If the degree on top is greater than the degree on the bottom, and I didn't tell you how to do the oblique asymptote, I'm going to wait a little bit because it's kind of a little long process. So I will tell you this right now, it's got to do something with long division. And then you trace the graph. That's the C on the T on the coat. And as you progress through the list above, so as you find all these things, you will start tracing it as you go. So the T is not, you don't necessarily do these things in the order that I'm showing you here. So the tracing kind of takes place all the way through the process. So you don't just hit this point and say, oh, I'm going to start tracing now. So, and then there's holes. This is also talking about domain errors, much like the vertical asymptotes. Okay, and if you remember, I said a while ago, once simplified, it is what makes the denominator 0. Well, what about before you simplify it? So before you simplify, you might cancel out a factor that's on top and the bottom, and that creates the holes. And I know this is a lot to take in, and but this part here, part 1, all I want to do is introduce all the things you have to do. Okay, my part 2 of this mini lecture will talk about a problem that will have a horizontal asymptote and a vertical asymptote, and that's pretty much it. And you will not have an oblique. As a matter of fact, I won't even cross the horizontal asymptote. So this will end part 1 lecture. But these are the things we'll have to do on each and every problem in this section. That's it.